Alright, hello and welcome. This will be the first video on this channel, and in this video I am going to show you how I made a pair of 1911 grips for a friend of mine with the help of my new CNC machine. This is a SainSmart Genmitsu 3018 Prover V2. The name is quite a mouthful. This is kind of the cream of the crop of the 3018, the tiny versions of these CNC machines, so that's the one I went with after doing a little bit of investigating on the internet. I watched a few videos to assist with the setup of the machine, but it really wasn't that hard, and following the included instructions, I didn't have a tough time, so I don't think you will either if you purchase this one. The first thing I did here was go to Etsy, and I was searching for 3D models of these exact grips because I don't have any experience in 3D design, especially not making things to a specification. So I found this one. The seller is called Best Digital Files, and unfortunately at the time of making this video, their shop is temporarily down. You may or may not be able to still buy the files, I don't know. But if you want to do something like what I'm doing, you can check out one of these other files. I'm sure they are all great. The one I got at $30, it's not super cheap, but it included the smooth version as well as the textured grip, which is what I wanted. I'll post the link in the description and maybe you can get it for yourself. Next up, I am going to basically recreate the project that I made in CarveCo Maker, which is the software that I'm using, just to show you kind of how I set it up. This isn't exactly how I did it the first time. I sort of made a couple mistakes, but there's a video that the manufacturer of the software made that I followed to do this. I will link that below because he has a lot more information and goes a lot more in depth than I am willing to do in this video. Alright, so here I'm creating a new model. These odd measurements are because I'm in inches, so that is 30 by 18 centimeters converted to inches just to get the full work area that I have available. The wood I used for this was two identical pieces of red oak that I had lying around for years. I cut both of these to 13 centimeters by 9 centimeters, which is 5.1181 by 3.54331, really weird inch measurements. In order to align the 3D model correctly, I made two rectangles with these dimensions in CarveCo, and I laid them out so that I could position the model to cut just one grip per each piece of wood. And I also set the resolution to the highest available when I was creating the model initially, which in theory should make a difference for 3D carves like this one. Next, I'm going to go up to import 3D model, and find my STL file that I downloaded. And then I'm going to mess with the X positioning a bit just to get them to sit perfectly centered between those two pieces of wood. I landed around 3.5, then I hit paste, and they are pasted down. Next thing I'm trying to do is set up the machine relief toolpath, which will machine the 3D model that we just set down. For some reason I get this box saying that points on the model lie outside the defined material, so I just set this up exactly like the production project that I did. It didn't do this the first time I set it up. I'm not sure why it did this time, but anyway, getting past that, we're setting up the toolpath now. First, I'm selecting one of the corncob end mills, and this is a slightly bigger bit that I'm using for the roughing portion of this. I will go over all of the settings and the differences between this demo project and the production project I used, but for now I'm just kind of meandering through them in this video. Now I'm going to select one of the tapered ball nose bits for the finishing portion of this job. This one's a bit smaller and it tapers down to a rounded point. And like I said, I will show you all of the settings that I used in just a moment here in a separate video. Once I've got everything set up, I will hit calculate now, and that will calculate all of the passes for the toolpath, which will take some time because of this 3D model. Now we've got this absolute red wall of passes for the machine to do, and it's still loading. Next, we're going to go up to the top menu and select Vector, Create, Relief Boundary. And this will automatically detect the edges of our model so that we're only carving what we need. We'll hit create boundary. And I'm going to set the relief to cut only the selected vectors and inside vector, which is what we just created with the relief boundary. Next, I'm going to go to the offset vector tool, and we're going to take what we just did and just make it ever so slightly larger so that we're not cutting right on the line that we need. And with these settings, we'll hit calculate now once again. And now we'll have just what we want with just the 2 grips being cut. Alright, now we're going to set up the custom lettering on these, which will be the initials of my friend I'm making these for. I'm making 2 circles that happen to have a radius of 0.35 inches. And I don't know how to center these within my model, so when I did the production project, I just centered them by using my eyes and trying to place them between these diamonds on the grip. I wasn't exact, I know for a fact. And it just rhymed. There's probably a way to center these within a given vector, but I don't know how. So this is what I did. I'm basically just counting diamonds here and trying to center it with an equal amount on each side, and that worked well enough for me. For these 2 circles, I will be setting up an area clearance toolpath. I'm going to use the same corncob end mill that I used for the roughing portion of the 3D relief carve. When I set this project up initially, I did have to play with the finish depth a bit to make sure that it cut through what was already carved on the grips, but did not go through the whole material. Obviously that would be an issue unless you want to have a hole in your grips. I did leave all of these settings as they were generated. They did not take that long in practice. And here I've simulated both the 3D toolpath as well as the area clearance, and you can see it created a circle on top of what we had already carved, which is the goal. Now for the lettering, I'll just take the text tool and I'm typing out GW, which are the initials in question. Originally I found a font on CarveCo itself that worked and I liked. And again, for these, I did not know how to center these within the circle, so I just did it by sight. There's probably a better way to do this, but I still haven't learned. I just wanted to get this done. So if you know how to do this, please tell me. Now I'm creating a V-bit carving toolpath, and for this one I used another Genmitsu bit. It is the 60-degree V-bit from the pack with the number VG03A. This company sells a bunch of different packs, and I think that some of them have the same bits in them, so they overlap. With that being said, it is very hard to find the exact tool that you're using, especially if you need to find it over and over. I'm guessing there's some way to save commonly used tools in CarveCo, but I didn't bother to figure that out before this video, and so here I am, complaining about it. Once we've got everything set up the way we want it, I will simulate all the toolpaths, just make sure that everything looks pretty much the way it's supposed to be. Next, I'm going to compare all of the settings I actually used to the ones that were generated in this demonstration project, and then I'll show you how I carved everything out and finished it up. Real quick here before we compare all the settings, I just wanted to show you the simulation of the toolpaths on my production project. I clearly messed up something in the demonstration, so this shows much more accurately what it's going to look like after each job finishes. This first one here is the roughing with that corncob end mill, and then we'll do the finishing pass, which takes a lot longer even to simulate, and it looks much closer to what the finished product is supposed to look like. Hopefully this gives you a better idea of what's actually supposed to happen. Alright, so I'm going to quickly compare the stock settings that are generated for these jobs that I showed in the demo project versus the settings I actually used in the production project to carve the grips. Up top here, we have both set to selected vectors based on the boundary that we made, and they are both set to inside vector. Here I'm just showing that both have the same tool selected, For these next settings, everything is pretty much doubled in speed. So the step over goes from 0.00591 to 0.01. The step down goes from 0.019 to 0.03. Not quite double, but you get the point. The feed rate goes from 13.7 to 26, so that's pretty much double. The plunge rate is set from around 6.8 to 12 inches per minute. And the spindle speed for both of these is set to 9,000 RPMs, which is the max speed for this spindle, at least I think. For the tool clearance strategy, I didn't change anything. I believe the raster was set up to go lengthwise, which would be with the grain in this case, so I thought that was fine. And the multiple Z passes, for the production project, adjusted the start Z, which must have been where the roughing job ended, at least that's what I think I was doing, and then the end Z would be the full thickness of the block of wood. I don't know if this is right. This is what I did though. Alright, and for the roughing job, I left everything as it is stock. I think this was fine. It didn't take nearly as long as the finishing job, which I will mention more about in a second. But all these are just the stock settings, so I didn't change a single thing. I just selected the corncob bit and calculated it like this. As for the Z slices for the roughing job, I also left this as is. You could do it manually and set, a more aggressive amount, and then it would take off more material each pass. I don't really know what I'm doing, so I just left it stock. I didn't use any lead-in moves, so we don't have to talk about that. And then the safe Z for the project that I actually ended up using, I set it to the width of the block of wood, but what I think I actually did here is I made the safe Z double really what it needed to be, like double above the 0 of the origin point. So as long as you set the safe Z to maybe about a millimeter above 0, it should be fine, assuming you don't have anything laying around like clamps or screws sticking out that the bit could hit and break on. Alright, last but not least, the material thickness was set to 0.472 inches because the blocks were around 3/8 of an inch thick. It set the origin to be the top of the block, and the Z bottom is negative 0.472. For jobs I've done recently, I've actually been using millimeters and measuring things with a cheap pair of calipers. This ends up being a bit more accurate and I think works better for CNC work, honestly. Inches are good for carpentry, but not great for this application. So the reason that I changed the speeds on the finishing job was because when I had originally put the job into G-Sender, it estimated it at 24 hours, and this seemed like an extremely long time to leave the CNC running. So I made the changes, and it got it down to 8 hours. However, when I actually went to do the cut, the machine would basically slow down every time it got some resistance from the wood, which was pretty much the entire time. And if you looked at the speed that it was actually running, it would decrease it by quite a large amount. I don't know if I ended up speeding up the job at all. I didn't measure how long it took, but it took a very long time. You might just be better off accepting the stock settings and running it, checking on it every so often, which is what I did. I would go out, every half hour, and vacuum it off and make sure that it was cutting correctly. I actually broke this down into multiple sessions because I was worried about leaving the machine overnight just because of how long it was taking, but this is not ideal because I basically had to save the origin point every time, and I suspect that the machine did not accurately save this and kind of got off every time I would restart the job, albeit by maybe a millimeter or so, but I do think it probably affected the end result. So if you can, just run the thing continuously, check on it to make sure nothing's breaking or loosening on the machine, but it would be better to just run this in one go. Alright, while I was talking there, you saw all the jobs run except for the last one, which is this profile. It's just cutting the grips free from the wood that they were carved out of. I could have done this in the 3D relief carve. I didn't realize that at the time. There is an option to do a profile pass. Either way, this works. Here they are in all their glory after all of the CNC work is done. I'm going to pop them off of the spoil board and get to finishing them. There were still quite a few fuzzy bits left over on the grips just because of the CNC, it's not perfect. So I'm using this Ryobi nylon brush wheel with my drill just to clean that up, and it did a fairly good job. And then I'm using, I think, some 320 grit sandpaper and just cleaning up the backs as well as some of the edges. This next portion, I really could devise a better system to do this in the future, but my CNC job did not drill all the way through the mounting holes, so I'm doing this myself. However, there's actually a peg on the gun that needs to fit through the back of each grip. I did not drill these the right way, so my friend ended up modifying them to fit properly. If you're gonna do this yourself, I don't know what to tell you. Be better than me. Initially, I was planning on using a polyurethane to finish these. Two things changed my mind. At the same time I was making these grips, my girlfriend and I were trying to refinish our kitchen table. We were not experienced in finishing things at all, and I had a very terrible time trying to salvage a goopy, uneven finish left by the cheap brushes we used and my terrible technique. I learned enough to probably be successful with it on these grips, but I didn't want to risk it. Then I saw this Reddit comment that sort of confused me. Then I saw these two comments which convinced me to use Tru Oil, which is a product made by Birchwood Casey intended just for this use. It's like a hardening oil that you apply, every 2 hours or so. I buffed it a little bit with steel wool in between coats, and I also used that nylon brush again. I didn't love the steel wool. It was kind of coming off onto there, so it would leave sort of metal dust behind. But yeah, I did probably 5 or 6 coats of that, and here they are. Hopefully you enjoyed watching this, and this was somewhat informative or entertaining. I had a lot of fun making these. It's a pretty ambitious project to pick for your first real CNC project, but I learned a lot, and they ended up working, so all is well. Maybe I'll make some more in the future, and I'll improve upon what I did here. Thanks for watching. See you guys.